Welcome to Emind's webinar on mastering AWS CodeDeploy with Jenkins and Puppet. We're really lucky today to have two AWS experts joining us, our CTO, Oron and our software automation engineer, Mihai Pantelimon. We'll be taking questions after the presentation. Our presentation will be about 45 minutes, and then there will be time for questions. You can submit your questions in the Q&A text box below. So let's get started. Oron?
Hi, good afternoon, everyone. Thanks for your time joining us for our first webinar. So we're going to talk about deployment pipelines, and this is the challenge of understanding why are they hard and how can we solve the problems that they present. So let's first try to understand why are these so hard. More and more companies deploy continuously, and even those that don't deploy more often than they used to. These frequent deployments happen on dynamic clusters that auto-scale in multiple staging, testing, and production environments. The pipeline needs to be designed, and it needs to withstand large peaks in traffic and still be highly available with no single point of failure. These are all production systems with users on them, and we need to deploy our code with zero downtime on a live system. This is a hard challenge, and more of our customers face this challenge with every new version they want to deploy. They come to us to ask for our help. They need us to build them a deployment pipeline which will ease the deployment process and lower the risk for them. So what we are going to show you in this session, by the end of this session, you will have the basic building blocks that will give you the knowledge on how you can build a delivery pipeline. This will allow you and your company to deploy your application AWS in a predictable and a repeatable way. And most important of all, it will be easy to use for the Jenkins UI. We do this using open source components freely available like Puppet and Jenkins, together with the new CodeDeploy service by Amazon. CodeDeploy is a proprietary service by Amazon, but it's freely available and there's no additional charge for using it. This delivery pipeline is repeatable and predictable. It works on any scale and is designed to support zero downtime and no single point of failure. A little bit about Emind, about our company and what we do. We are an experts company. We are doing cloud and cloud only since 2007. This is actually when AWS was a year-old baby with no console and the only an API for those of you who remember. We focus only on the DevOps and continuous integration delivery parts and are doing only that. We work with all the major cloud vendors, AWS, of course, Google Cloud, and Azure, and we're also a reseller of these platforms. In the last 7 years, we deployed over 900 different applications to these clouds. We are the Israeli market leader, and our architects and DevOps teams can take your product all the way to success. I think this is a good point to transfer to Mihai, who is our own CodeDeploy expert and automation, leading the automation efforts in Emind. So Mihai, please take it from here.
Thanks, Oron. Hi, everyone. I'm Mihai Pantelimon. I'm a software engineer with 7 years of background in Java and C++ development. And since 1 year ago, I embraced this new opportunity of working in the cloud by becoming a part of the automation and development team at Emind. We as a team try to help our customers automate their processes in their cloud systems. And as part of this job, for the last 5 to 6 months, I've been working on developing and continuously improving a CI and CD solution for the AWS cloud. For those of you who are not really familiar with the acronym, CI and CD stands for Continuous Integration and Continuous Delivery. The solution was developed for both Linux and Windows, and is centered around the three components Oron already mentioned, which are Puppet for configuration management, CodeDeploy or as a deployment coordinator, and Jenkins as the orchestrator of the build and deploy system. Now, a few words about Puppet, because you may remember that the original title of the webinar mentioned it as a masterless and nodeless Puppet. So we changed the title a bit because we felt Jenkins deserved to have a part of it. But I still need to mention we are using a masterless and nodeless Puppet. So what does masterless mean? It means that each machine acts like its own master. The catalog compilation is done on each machine, and in this scenario, the versioning control system becomes the central configuration repository. And the nodeless means that you no longer have to define nodes individually, so that Puppet runs according to instance type details calculated according to facts, which in the case of a cloud, it can be very well instance metadata like tags in the Amazon case. So we could say it's like a fact-driven Puppet. Now some words on CodeDeploy. This is not meant to be a beginner's training on CodeDeploy, but rather an introduction or a reminder, so as to make sure everyone has a minimum level of knowledge and understanding on what it is and what it does exactly. So by definition, Amazon's CodeDeploy is an AWS service which helps coordinating application deployments to groups of instances, which can be either EC2 instances, on-premises instances, or even auto-scaling groups. And I found this diagram on the CodeDeploy user guide, and I borrowed it because it really shows all the components of CodeDeploy. So CodeDeploy aims at answering three questions. One is what we want to deploy, second, where to deploy, and third, how. And for the first question, you have the box in the bottom left corner of the diagram. And this is where we prepare a revision meaning a deployable version containing deployable content like source code, build artifacts, web pages, executables, you name it, and deployment scripts that are to be executed by CodeDeploy. Plus, there is a metadata file called an appspec, which basically specifies exactly where each file should be copied to and which scripts to be executed in which order. So once we have such a revision prepared, command in CodeDeploy creates a zip archive out of it and uploads it to the S3 bucket or even a GitHub repository. Now for the second question, where to deploy? In CodeDeploy there is a concept called deployment group, which is basically a group of instances identified simply by tags or by auto-scaling group names. And each of these machines runs inside of them a piece of software called CodeDeploy agent. And this functionality of the CodeDeploy service communicating with the individual agents makes the whole process platform agnostic. Finally, the third question would be how to deploy, and this is where another concept comes into play called deployment configuration, which is basically a constraint that determines how a deployment progresses through the instances that comprise the deployment group. So once we have this defined, that we can very easily do from the Amazon console or from CLI. The next step is to trigger the deployment. This is the step number 3 in the diagram. And at this point, depending on the deployment configuration selected, when the order comes for an instance to be deployed to, the agent goes to the S3 bucket or the GitHub repository and fetches the revision to deploy to. And based on the instructions specified in the AppSpec file, we'll copy the files, the deployable content, and run the deployment scripts. Now, why exactly did we choose CodeDeploy? Before that, we were using mCollective as a way of doing deployments in AWS, and more specifically for kicking off Puppet runs on remote machines. And we used it because it's an integral part of Puppet, but it came with a lot of pain points, which CodeDeploy manages to successfully solve. And the main ones are the predictability of the deployment. The mCollective was using a machine discovery mechanism based on timeouts. A machine, if not answering in time, was simply skipped from the deployment, and we didn't get any kind of warning, at least. In this case, being part of the Amazon infrastructure, everything comes natural when it comes to machine discovery for CodeDeploy. As I said already, this is based on machine tags. Then the deployment tracking, there was no way of verifying the status of the deployment in real time with mCollective, but it is with CodeDeploy, when we can actually see the status per machine and for each machine per deployment phase directly from the management console. The third pain point would be the system downtime. We had to engineer it ourselves with mCollective in our application to be able to simulate kind of a rolling update. But in CodeDeploy, it's as simple as specifying which deployment configuration to use, and the rolling update will become natural for the CodeDeployed application. Regarding the rollback, actually there is no automatic support in neither of mCollective and CodeDeploy, but in mCollective, again, we had to engineer it ourselves in the code to support such rollback. While in CodeDeploy, it's as simple to simulate as just deploying some previous working revision. And finally, the use complexity, well, there can be no argument here that the management console's UI is rather trivial to use when compared to triggering MCO CLI commands. A little bit about the rolling update, because this is where a lot of heavy lifting is done by CodeDeploy. And the rolling update, as I told you, is based on deployment configuration, which is nothing more than a health constraint. Actually, this specified the number of hosts that are to be kept healthy at all times during a deployment. And actually, CodeDeploy comes up with 3 built-in deployment configurations that you can find in the console in a drop-down list, and you can select either of them. These are all at once, half at a time, and one at a time. The first one starts all the deployment on all the machines simultaneously. The half at a time attempts to keep at least half of the fleet up all the time, and one at a time is the most conservative but also the slowest, and it attempts to deploy each machine sequentially. This is probably the most useful one for a production environment. but also if one machine fails, then the deployment is considered to be failed altogether. These health constraints are based on 3 parameters, basically ways to define how many hosts you want to be kept healthy all the time. And if you are not satisfied or none of this built-in configuration suits your needs, then you can create your own custom deployment configuration. You can do it only from CLI or API. And what you have to do is just specify one of the health constraint keys and one value for it. Going on, I'm going to show you a real case of an architecture we developed for one of our customers. Part of it, as the whole architecture is much more complicated than I discussed so far, is not of real interest for today's discussion, but just aims to show you how complex the entire solution has become. What you're interested in here is that we have Jenkins as the orchestrator with 2 jobs defined in it. One is the build job and one is the deploy job. And the build job, except doing other internal kitchen stuff, is also communicating to CodeDeploy and prepares the revision. And when triggering the deployment, again, Jenkins communicates with CodeDeploy to run this previously prepared revision to the selected deployment group or environment in this case. What happens at deploy time is that a number of deployment scripts are executed in order. The first one attempts to deregister each machine from DLB it is part of, if any. The second one attempts to update the code, including the Puppet code, and run it to finalize the update of the whole application and the configuration. Then log parser script is run. This is a way for us to determine the deployment status, the success or failure of the deployment on a machine. If the deployment happen to fail, then if this log parser signals an error, then the entire deployment for this machine is considered a failure. This happens for all these phases. And depending on the deployment configuration, this may abort the entire deployment or not. Finally, the machine is attempted to be registered back to DLB if it was previously registered to 1. All right, I told you earlier that we are using a masterless and nodeless Puppet. And now I would like to let Oron tell us why exactly did you choose this masterless and nodeless approach, and why it is the best approach for us. So, Oron?
Okay, so basically, when you're using Puppet was designed in the beginning with a master in mind. So there is a single point of failure in this case where the master is accepting requests from hosts that want to be configured and is sending the manifest and everything to these hosts. Now, when you're working in production environments and you want to have a high availability and have something that will not fail when the cluster is auto-scaling and things like that, you have to design really a cluster of Puppet masters. So building this cluster, maintaining it, and syncing the manifest between the different masters is a big headache. And we prefer to work in the terms of masterless, so you don't need to sync the manifests and the code. The manifest is really the code that describes the infrastructure. And this is error-prone. We much better use Git to sync the manifest into the instances. And this is the single source for truth for the manifests that go into the machines. all the manifests are pulled off Git, and another option is to use something like an internal Linux repository, which is highly available. It's easy to have them highly available. It's just an Nginx with a disk. The manifests are deployed to each of the instances, and we just run Puppet apply locally. So it's really like every host is its own Puppet master. This eliminates all the drawbacks of Puppet master, so no single point of failure. It's a very scalable solution, so there's no denial of service on the master by a cluster that's scaling up or down. There's simpler network requirements, and there's no need to configure certificates. For those of you who know Puppet master, it was more designed to say bare metal or real servers scenarios. So you need to sign the certificates. This prevents you. This becomes irrelevant when you work in the cloud. The only drawback here is that there's no central dashboard. The Puppet Enterprise works with the master and the dashboard that gives you some sort of reports on what's happening with your deployments, gathers information by hosts connecting to the master. So this is something that you lose. On the other hand, we can look at the status of deployments by looking at the CodeDeploy in the Amazon console. This is some sort of a solution for that.
Okay, so we've seen two of the components being justified. I feel like I need to say a few words about why you chose Jenkins. Well, it's a very easy to get started with tool, and it was specifically of big importance for us since at the end of the development we have to hand over the solution to our customers, and their engineers may or may have not worked with Jenkins before, and it's real easy to catch up, at least for what is needed to operate this automation solution. Then it's probably the only open source solution from all the big continuous integration programs, with a lot of plugins and very good support throughout the community. And this was again of big relevance for us, since the dynamics of the cloud imposes us to adapt to every new feature or change. Actually, we had to add support to one of the Jenkins plugins for our Windows solution, and it was straightforward to do it with the help of the support people of the creator of the plugin and the open sourceness of the components. Finally, there is a table I found on the Wikipedia page, and you can find the link in the presentation. Basically, Jenkins supports more versioning control systems than all the other CI solutions. And again, this was important for us since all the customers we've had so far had different versioning systems, like either Git or SVN or TFS. And this is how the dashboard looks like in a simple case scenario where you have two jobs. One is the build job, one is the deploy job. And operating them, it's as simple as just clicking on this icon on the right-hand side of the line, which would open up the screen that you can use to run that particular job. So for the build phase, what the user should do is just to select the environment to build for, in this case the development. This is a drop-down list that we populate according to the customer's needs, and specify the application version to build. The same manner, the deployment is just a matter of selecting the environment to deploy to, and selecting the version to deploy, which is can be selected from a list which is pre-populated with all the versions that were previously created with the build job. So this is a way of helping users, not having to introduce the version themselves. Okay, we had an overview of all the main components. I guess it's time to have a demo. And for the sake of this demo, I just want to briefly present you the architecture so that it will make much more sense to you. There will be a Jenkins setup with the two jobs that I mentioned, the build and the deploy. There will be an environment, deploy environment containing 3 machines, 2 of them running in the Oregon region, and 1 of them in Sao Paulo, in South America. And this is where I must thank Arthur for the inspiration. He really inspired us to present deployment in other regions using on-premises instances, which is a relatively new feature introduced by CodeDeploy. So in Oregon, we have 2 machines. One is tagged with the environment tag dev, and the other one is with prod. And the machine in South America is also tagged with the environment dev. Deployment group will contain the dev environment, and this is why the deployment will be propagated only to these 2 green box machines. And I will leave the presentation mode to explain you a bit more about the components. So we have the 2 machines prepared here with the tags well defined. We have a load balancer with both machines that are running in Oregon in it. This doesn't make much sense, of course, but for the sake of the demo, I wanted to show you how the machine leaves the ELB and joins it again after the deployment. We also have a CodeDeploy application, and this is where the deployment group was configured to use the environment dev. Finally, we have the S3 bucket where all the CodeDeploy revisions are stored, and we already have 3 pre-prepared revisions from our earlier testing, but we'll create a new one. And the application that we'll deploy is just a simple Java application that displays a web page. What's important is that this web page displays 3 pieces of information which are configurable through a configuration file. And of the utmost importance are the version and the environment, and I'll show you why. This is how the application running in the 3 machines look like. Basically, we specified the name, but this is only for being able to check what machine we are talking about, the version that it's running, the software version, the application version, and the environment that is defined through the tags that I showed you. So we have this dev machine in Oregon running version 101. We have the prod machine in Oregon running an earlier version of the application, 100. And the machine in Brazil also running 101. And what I'll do now is try to simulate an application new version. And I'll do this by incrementing the version here, save it, and I will commit the change to Git. And right now, I am waiting for the new version to become available in Git. And I must mention that Jenkins has 2 ways of working. You can either do the Git polling, trigger it manually, or have it triggered on specific hooks so that you can run a build job automatically after a new commit is pushed to the system. But for the sake of this demo and actually our solutions to offer the biggest flexibility maybe for the engineers of the customer, we separated these two phases and we'll trigger the build manually. And I'm doing it from the build job. I'm selecting the new version that we created. And now Jenkins offers a console with the progress, so you can see now how the Git repository was updated. There is an extra step that we do into verifying the Puppet code for code style warnings or compilation errors. And finally, the AWS CLI command for deploying, actually for creating the deployment and pushing the revision to S3 was run. The build was successfully finished. And if we go back to the dashboard, you can see this is the status of the latest job run. And this is an icon with a weather-like metaphor for describing the stability of the build based on the result of the latest several builds. So this is all green for now. We have the new revision ready, and we should find it in the S3 bucket. And now if we go back to Jenkins and attempt to deploy this newly created revision, we get the new version populated in the drop-down list. And I'm selecting build. In this case, we can also try to see the detailed status per machine and per deployment phase from the console. We see the deployment has already been started. It contains 2 instances, just like we intended, which are the 2 dev machines, one in Oregon and one in Brazil. And if we go here, we can see the detailed status per machine. Going further on, we can see the 7 deploy phases, or also called in CodeDeploy terminology, deployment lifecycle events. And after all the status cells become red, this means the deployment finished for this machine. And the next one will start. That's because we selected one at a time deployment configuration. This was actually the machine running in Oregon. And if I go here and attempt to reload the page, I should see the version 103 appearing. Also, the same thing should happen for the machine in Brazil. And by going to Jenkins, again, we'll see that the deployment finished, and it only lasted like 1 minute and 30 seconds. So this is basically an indication of the time spent on miscellaneous stuff and behind the scenes task that CodeDeploy takes care for us. Now, I'd like to demonstrate one last thing, and this is the possibility to tag the machines. And I'm doing this by simply retagging the prod machine to dev so that we can hopefully make it take part in a deployment also. So I change the tag to dev, and I go back to the Jenkins console. I remember that the prod machine was running version 100, and from Jenkins, I'll say let's upload, or let's upgrade to 102 and downgrade all the other machines back to 102. So I'm re-triggering the deployment task. If you want to do fine-grained monitoring of the deployment status, you can do it from the Amazon console. But if you want to have an overview of the entire deployment, you can see it from Jenkins, where the Jenkins job will track the full status of the entire deployment and finish when the full deployment is finished. And if I go here to the ELB, I should see that one of the machines, the prod machine in Oregon, has left the ELB, meaning that it's turn now for being deployed to. I'm going back to look at the progress per machine. And this is where we know that this machine has finished with the deployment. And this actually happened to be probably the prod machine, which should now rejoin the ELB. So the prod machine rejoined the ELB, but the dev machine in Oregon left it to be deployed. But if we go to the page of the prod machine, we'll see only not that the version was upgraded to 1.02, but also that the prod environment was changed to dev. And this is done by virtue of Puppet, which takes care of gathering all the machine tags, creating effects from it, and using them further on in the application configuration. So I guess this was enough for the demo part. I'm going back to the presentation mode. And I'd like to say a few words about the pitfalls that CodeDeploy has, because it's not only milk and honey like we've advertised before, but there are also some pitfalls with CodeDeploy. This is the bad news, but the good news is that we managed to have workarounds for all of these 4 pitfalls. And probably the major one is that it's only supported in 4 regions for now. But as I showed you, we can use the on-premises feature to deploy to other regions, like we did to the machine in Brazil. So this is one of the pitfalls we had to work around for. The second is that you cannot delete your revisions from the console. And this makes the deployment from the console be really hard to go on with because of all the historic revisions stored there. The revision history quickly becomes cluttered with useless crap. So in this case, what we managed to do was to hide everything behind Jenkins. So now you do the deployment from Jenkins, and behind the scenes, you don't care how many revisions have been created before. You just see the drop-down list with all the versions you can deploy, and that's about it. Thirdly, there are some rolling update scripts for Linux, and they're available on GitHub by the Amazon team, but there was no support for Windows for such thing. And we actually had to create those scripts ourselves in PowerShell. So this is also checked. And finally, there is no way to pass arguments to the lifecycle event scripts yet. This was also worked around by us by design. And this basically strikes through the entire list. And I have a slide here detailing a bit of details on this solution of deploying to other regions by using on-premises instances. And if you want to do it, I must instruct you to follow the section which says manually configure and register an on-premises instance from the CodeDeploy user guide. This is because the automatic procedure will fail It doesn't support taking EC2 instances and considering them as on-premises instances, but the manual procedure works, and we are currently working ourselves towards creating an automation solution to make this automated in our CI and CD architecture. So once you follow all those steps in the procedure, what you do from the code deploy perspective is tag the machine. You do this from the code deploy console this time. You select tags just like you do with the normal EC2 instances. Then when you define the deployment group, you can select the tag key and value just like you do for the EC2 instances, and then there's a proof that the deployment to another region actually succeeded. Now, in terms of integration between Jenkins and CodeDeploy, there is a plugin developed by the Amazon CodeDeploy team, but we found it to be really rudimentary, too basic for our needs, because it does not allow the separation of the two phases, the build and the deploy. You can't really configure the destination of the deployed files. It uses the same path as where the content is found on the deployment machine, the build machine, and finally, there is no way to define hook scripts. And this was of big importance for us in order to run Puppet at deploy time. So what we did is actually use AWS CLI commands from the build scripts in Jenkins. This way we managed to obtain full control of the entire flow, and all the three phases of preparing the revision, of pushing it to S3 and to deploy it further on are attained with this fine control scripts. To summarize what we talked about, if I were to say it in one phrase, I would say that now with this solution, the deployments in the Amazon cloud are only a few clicks away. And we do this with Puppet as a configuration management tool, with CodeDeploy, which quickly becomes the de facto deployment tool for AWS, and with Jenkins as a cross-platform, easy to use and integrate with CI solution. And what the customer needs to do after handing over this solution to him is just play with the machine tags, configure them through the tags from the console, and then triggering the build and the deploy jobs from Jenkins with only a few clicks and keystrokes. So I hope I was clear enough in my presentation, but not enough so that you don't have anything to ask. So we're just waiting for your questions now.
Okay. Thank you, Mihai. So I just wanted to open it up to questions. So if you have any questions, you can ask them in the Q&A box. We have a few. And if you'd like to reach us after the webinar, you can reach Oron. His email is here. Mihai's email is here as well. And for any general questions or information, you can write us at info@emind.co and follow us on Facebook for more updates and events like this. And of course, our website, eemind.co. So I'm going to go to the first question. It's from Itai. And he asks, are there template files for the app spec file? For example, an aspect for a general Java Play application. So, Oron, do you want to take that?
Okay, so basically the app spec file is very generic. So you can put any bash commands there or any other shell commands. So it's only a matter of finding somebody who already developed something for a Play application, but it's really a very non-specific file. So if you can find somebody to share it with you, great. But I don't know of any templates that AWS give. But maybe Mihai knows more.
No, we have some samples to demonstrate the different sections, but this is about it. They don't try to solve any specific problems with templates.
Does it work with other WebGit repository providers such as Assembler and Bitbucket? Do you guys have anything to say about that?
So as far as we know, right now only GitHub is in place. I'm sure that it's a pretty new service. It's only available in part of the regions. They're going to introduce, I think, more providers and more features. This is the way Amazon has been working always. They release something which is works pretty well, but is lacks features sometimes, and they gradually add the features as they go. So I would expect more providers to be in there.
Okay, thank you. We have a comment from Roy. If you work with the ENC, such as Foreman, you don't need to sign the certificates. The Foreman server signs the certificates. Do we have a comment about that?
Okay, so this is true. This still doesn't solve the problem of being a single point of failure. So if the ENC goes down, new nodes won't be configured. So it's still the headache of creating the cluster of formans. So it solves some of the problems, but we're still facing the problems of creating a cluster of machines to handle all this Puppet mastery.
Okay, thank you. We have a question from Tarun. Where do you configure what all packages to install in Puppet when a new machine is created in the auto-scaling group?
So Mihai, maybe you take this one.
I'm not really sure I understand the question.
Okay, so where do you configure packages?
Which packages to install? I assume that the meaning is like how you define the role of the machine. Like how do you know which packages to install when the machine is created on auto scaling?
All right, I got the question. Yeah, actually, we didn't have any deployment so far with which contain auto scaling groups, so it's not part of our solution right now. But probably we can figure out something and come back offline with a proposal for a specific case.
Okay, so Tyrone can take it offline with you. Okay, what about, you mentioned log parser. Is this provided by CodeDeploy or is it a custom script?
Who is asking this?
This is also from Tarun.
No, the log parser was a specific example for that particular customer. Of course, for some of them it's not applicable, but there is generally a good thing to have some way of verifying that the deployment succeeded in some strict way. So it was created by us from scratch. In that case, it was just a Python script, but there was just more like, during the presentation, more like a placeholder for the phase where we want to verify the deployment outcome.
Okay.
By the way, this is maybe a good time to say that there are the devil is in the details. So this is a good time to ask any of you that want to talk to us further. Contact us. We will be happy to discuss the solution and help you implement your own delivery pipeline.
Great. Thank you, Oron and Mihai. And like Oron said, be in touch with us, and we look forward to seeing you at our next webinar. Oh, and by the way, there's a poll that you can fill out. Just go to the polls down below, and you can fill out a quick survey. Thank you.
Thank you.
Thanks.